Now we're going to take a look at class methods and class variables. We're still using our same structure of classes, but what we're doing is we're trying to understand the difference between the object, which is an instance of a class, and just something that is part of the class without using an instance of a class, such as so it becomes a little bit tedious to always have to create an object, especially when we have a simple function that we need done, or access a common variable. So for example, we want to keep a variable that is a counter of some sort, and for every time we declare an object, we want it to just increment that counter. We don't want that variable stored in each of the classes. We want something that's shared among the classes. Or the method we want to be called without creating an instance of the object. And we will do this using the keyword static. So this is our previous example from before where we have our geometry class and we've declared an instance of the object rectangle defined as R, and we can access our methods using R. So if we want to tell Java that we want to use a method without declaring an instance of an object, or even a variable without an instance of an object, all we need to do is put the keyword static in front of the method declaration. And very simply what we do is, in this case, here's an example. If we look at the rectangle class, we have a variable called count, and this is a type integer, which we've initialized to 0. By declaring it as static, we basically are going to say that there's going to be one instance of count that is going to be a shared variable for any of the objects within rectangle, or whether an object was created or not is actually irrelevant. However, for this example, it is relevant because we increment count when the constructor is called. So when we have rectangle r equals new rectangle, that calls the noarg constructor, which will increment count. And we do the same thing for R2 and R3, which will then increment count again and again, so now the value is 3. When we want to reference count, we simply can do one of two things. In this case, we can access the direct variable by rectangle.count, because count itself is static, and we can reference it directly, and it's visible in this case because it's public. We can also access the method called getCount, because getCount, which also returns an integer, is also defined as static and is public as well. So when we want to go after a variable or a method that is what we call the class method or class variable, we simply don't just need to use the class name in front of the variable or method, and there is no object for that. Finally, since the beginning of the class, we have used this public static final void main string bracket bracket args function. And it's interesting now that we have enough information to understand why this has to be the way it is. Why do we need all of these keywords before main? Well, first of all, the main keyword is just a starting point. Java knows that main is where it's going to start and it must be in the public class. But this function must be declared public so that it can be visible outside of the class. We understand this from the access keywords that we had before. So in order to run the program from the command prompt, the JVM needs to be able to have some visibility into the public class where this main function is. And so therefore the method must be declared public. Second, the method has to be static because we cannot create an instance of an object because we don't really know anything about the class itself except that we want to run the main function. And it is there where we can then begin to create objects or call other classes. Third, it has to be void because it's not going to return anything from Java back to the JVM or to the command prompt. So by definition, it has to be void. And finally, no pun intended, number 4 is that it should be final. This is an option. It's optional. You don't need to put the keyword final, but the method, so that the method cannot be overwritten. There is some optimization that occurs when you have a final method, so it is a good practice to actually put that in there. And that closes out the class variables and class methods.